a really awesome intro song. I need to actually have that on like an action trigger in my office at home, just when I come into the office. It'd be great. One quick correction, I am no longer a developer advocate. I am now a sales engineer. So as I like to say, I've switched from developer advocate to devil's advocate. But that's just what I'm doing these days. Essentially the same thing as a dev advocate. I just talk to enterprises. But today's product is not salesy at all. In fact, Hasura is an open source product. So everything I'm going to show you, totally free. And we're talking about Postgres, which is like the grandfather of free. So skipping the queue, event-driven programming for everyone with Postgres. What do I actually mean with that? Let's go ahead and start off real quick. I have the intro already. I am a dad of 4. There will be dad jokes. They're really rough ones. Please be gentle. One of those kids is actually 1 year old, so I'm really tired. But I'm a GraphQL advocate. I've been doing that for about 6 years. So if you have GraphQL questions, we can kind of talk about that. I think the intro basically covered everything just fine. A little bit about what Hasura is. Basically, it's instant APIs on data. I've just lost my slides, but no big deal. There we go. Let's give it a little tap. Actually, I've lost the screen there. Let me go and see if I can bring it back here. Looks like I need to just switch over to that page. That works. So we're used by companies of all size. I wish more of them would pay us, but that's not the case. We have basically users of all types. If you're interested in instant APIs, have a look at it. I'll show you a little bit what it does later on. But moving on, I'm just going to give you a quick warning here that this is a product person's perspective. I'm a builder. I make products and applications. It's good to see you. We have Hasura fans in the audience. I love it. And so from that perspective, there will be some technical depth, but I'm going to talk mostly about a perspective from building products, or how do you build with this sort of approach, and specifically event-driven programming. So biggest point I want you to take away from this talk is that it is good to embrace boring tech. Postgres, super boring, super stable, super solid. You can actually get really, really far with Postgres. Don't add unnecessary complexity. And for any of the students in the room, the second big point I want to have is that this is accessible and approachable for everybody. Like, if you don't overly complex your architecture, anybody is able to actually build this way. So I hope you maybe are a little inspired to give it a shot. So let's dissect the title here. We've talked a little bit about the everyone piece, but let's talk about what I mean with skipping the queue, and let's talk what I mean about event-driven programming. So the two points we need to cover here, we're going to break them into questions then, is what is event-driven programming, and what do I mean with queues, and why should we actually skip them? Event-driven programming, who here already does event-driven programming? Not enough. Not enough, but that's good. Maybe you'll embrace it after today's talk. Event-driven programming allows you to reason about your architecture by behaviors. It allows you to be composing services that will do one thing, followed by another thing, followed by another thing, instead of sort of a waterfall behavior where you're expecting an async behavior, like a waterfall to go on all the way through your application. So in this case, we have 2 different microservices, one for paid functionality, paying for an order, and one for shipping an order. And we can just allow the client to sit there and chill without having to do anything while in the background things are happening. We've actually all experienced event-driven programming, right? So you know the effect of trying to pull down and see if Twitter's updated or whatever else. I don't know if you guys are Twitter users here. Twitter users? All right, follow me at MotleyDev. So we know polling pretty well, but the events is actually where you get that push notification. We're actually able to get something that happens real time. But there are actually challenges with event-driven programming. There's a reason why not everybody's embraced it right away. Cold starts is a big one, and that means that these microservices I have aren't actually booted up and running yet. So maybe the event that I've sent off somewhere is just getting dropped. Nobody's listening for the event to arrive. Order of delivery. It's first dad joke. All right, everybody's awake. That's good. That's actually, in some cases, I need to handle these events in a very defined order. And second is acknowledging receipt. My main system that is sending off or triggering these events needs a way to actually say, hey, have I actually already done this work? Did you receive this task? And these are some of the challenges around event-driven programming. So we have queues, right? Queues are fantastic. They allow us to handle these kind of functionalities. We can stuff a whole bunch of events and then eventually be able to address each of these events one at a time, throttle down the system, and it gives us the ability to not overwhelm our microservices and sort of just handle one at a time. The rough structure of event-driven programming, I have a queue of a bunch of events, and then I'll handle one on a worker, and I can have as many workers as I want that essentially just process the work. Queues get fancy. They can send acknowledgement of receipt. They can tell the original source, hey, I've got it done. Everything's fine. They can be throttled. There's a lot of functionalities that queue softwares offer. There are very many valid use cases for queues. So where are queues really helpful? Well, when we have massive amounts of data, if we need robust features for events, like I talked about, handling cases of the different, like if we wanted to say, has this service been handled by which region? Has this event been processed already? And then the last second dad joke is queues are helpful if you live in Germany. I'm from Germany, as you can tell from my accent. No laughs about queuing in Germany? Come on, everybody. Okay. My title says skip the queue, right? Well, when do we not need queues? I was not sure if that was a noise in my ear or if that's a noise out there. So I have a warning, and this is the last dad joke I have. This is the worst joke I have ever written. Okay? Are you ready for it? Where are my queue people? How many people are using queues already? All right, this one's for you all. No bull. Queues can be a pain in the Kafka. That's nothing to sneeze at. It's the worst one I've ever written, but this is probably one of my last talks in a while since I'm no longer DevRel. I had to land it. These are all queue management softwares that I've put into one joke because it's really funny because I'm a nerd. All right, yeah, dad jokes. I had a little qualifier in there. All right. Okay, so what's the underlying problem with using queues for everything, and why can we potentially skip the queue? Well, not all events actually are the same. If we look at these different transactions here, Postgres can handle over 20,000 transactions per second without getting overwhelmed using its built-in event management system. Is order actually important for the events that I need to handle? Is this a stream of data? Like, is this something that's going to be one piece comes after the next piece, or is it maybe 20,000 discrete events where I don't actually need to worry about who gets handled first? And am I doing data I/O already? Like, am I already going to be essentially queuing up events to be inserted into a database to begin with? If I'm going to be doing I/O, living at the data layer, maybe I don't need a middle queue software. And frankly, from the client's perspective, we're back to this little architecture here. This is one atomic event, right? They don't care. They've paid, and it's done. And from their perspective, they only want to know when one thing is done. They don't care if somebody else got handled before them. They don't care if somebody else paid first and got shipped first. They care about when their stuff is notified that, hey, everything's on its way. So that leads us to the question, what's something that's queue-like, supports events? I just realized that color does not scale well. I apologize. Is well understood and or exists in many tech stacks and sits close to the data. Any guesses what that might be? Somebody, come on. There we go, Postgres. Anybody using Postgres already? That's why I love Europe. Yeah, so Postgres. And if you want a really interesting read-up on this, Pete Hunt actually did a really great architectural teardown about when they were working on Dagster, about actually how they were able to rip out Kafka and be able to replace it with Postgres for their queue management software. Because the fact is, queue management software, and I'm not picking on any one of them in particular, is expensive. And like, these are really valid points. Like, you need to learn how to use it. You actually need to be scaling up teams that are managing just your management layer. And this is all pieces of data that really adds on to the complexity, gatekeeps abilities for developers to kind of grok the system, and so it may not be needed. So, okay, I do have one more dad joke. Most people don't think that the Q in Postgres actually stands for queues. And most people are right about that one. But also many people don't realize that it's good for job-related queues, and it totally is. So using Postgres for event-driven apps with queue-like behaviors, it's already transactional in nature. It supports events out of the box, and it supports relational data. One of the big gaps and flaws with current queue software is you have no relational data. You have to queue your event, then you put that into a processor, you fetch all the related data, you bring that back into another microservice to process that event, and then you're able to do what you wanted to do. But Postgres is already relational. It already has all the data right there for you to handle your events. So, event-driven and queue-like. So how do you do this in Postgres? We're going to go into some slightly more technical pieces here. Bear with me. We're not going to go into a full SQL land, but essentially it works this way. Postgres supports two different kinds of events. There's data definition language events, like create, alter, drop, those kind of behaviors. There's DML, data manipulation events, so inserts, updates, deletes. You can tap into any of these sort of events in Postgres and be able to do something with them. And then you're able to create server handlers in Postgres, foreign data wrappers. Anybody using foreign data wrappers? It is like the most slept-on technology in Postgres imaginable. If you want to really get a mind trip, go look at foreign data wrappers with Postgres, and you'll wonder why any other database exists. Somewhat, but it's that powerful. You really need to have a look at it. And then you basically create this foreign data wrapper, something like a create server handler, and then you call that as an extension for your SQL. And so I'm intentionally not making this bigger because I don't want you to do it this way. But you can use a foreign data wrapper library, something like Multicorn. Anybody heard of Multicorn? Yeah. You're all going to have your brains blown when you look at Multicorn. It's really insane. So Multicorn allows you to create all kinds of really weird extensions in Python. You can then call those extensions inside of Postgres. You'll do something like creating an extension here, create a server, and then be able to pass in where you want to handle the data. Then you add an event listener that's going to be able to say, OK, whenever some data capture changes, I'm going to call this extension. And essentially, you have a flow for event-driven programming inside of Postgres. This is not fun. This does not scale for teams. It is definitely doable out of the box. And if you need very simple use cases and it's just you building, then why not have a look at it? Like, it's totally a reliable approach. And the rough flow that's happening here is you have essentially a DML event that's going into some kind of a read state, and then you're going to call a stored procedure on that event. Postgres has a built-in event table. So who would like to see the easy way of working with Postgres event triggers? And again, you guys can try them wearing the T-shirt. It's going to be a Hasura thing. Again, I really want to stress this is open source. Like, this is totally free. They do pay my salary. I'm grateful for that. But like, this is free. So as I like to say, take the money and run if you want. If you're a big enterprise, do talk to me. But if it's something that you're wanting to have a look at, this is going to really hopefully help the way you're going to build. The way that Hasura handles Postgres events is we do sort of a combination between using the built-in Postgres event table, so capturing those change data captures, but then we're going to essentially store any change data capture. We're going to stuff that into a secondary table that is the full JSON payload of that event capture. So as soon as Postgres says, OK, I've done something, we take that, we listen to that capture, take that, convert it into JSON, and just store it. And then we actually have a process that will go through you to find some different handlers inside of the Hasura platform, and it processes this table built inside of Postgres already, and we'll go ahead and handle the different functions you need. So before I go to the code demo, I just want to say there are some resources. This is meant for online viewing. If you are interested in any of this kind of content, this is an architectural pattern we've had online for a long time. The easiest way for all these links is actually to find me here on Twitter. I've got this list here. You can see that I posted it not too long ago. This is a link to all of the resources that'll help you kind of find your way. But I'd like to show you exactly how this works here. So let me go ahead and see if I can switch to a mirrored mode, and we'll do a little live coding demo, because why not? We're paid to hate ourselves in DevRel. All right, so I'm going to go ahead and switch this over to screen mirroring. And with mirroring in place, we're going to go ahead and have fun. Little free promo there. Anybody heard of OrbStack? Anybody here use Docker? And those who are using Docker, who are Mac users? Okay, look up OrbStack. It will change your life with Docker. Really, really fantastic software. Okay, so what we have here is the Hasura interface. What we're going to do is actually go ahead and initially do what I talked about, the creating data APIs. So I'm going to go ahead and track a table, and the table is actually following the same paid, shipped little architectural diagram that we saw earlier. Why make things overly complex? What I need to do is, at the moment I have no API, I'm going to go ahead and create one by using the Postgres connector here. I'm going to just name mine default. And I'm going to go ahead and use an environment variable that I've stored. And because I don't care about security, I use copy pasteboard history, so that's no problem. And we're going to go ahead and just track this. What the engine's going to do in this case is it simply goes ahead and it sees my existing database. It introspects my schema, and it says, hey, I found some tables or models, if you will. And it says, do you want to track those in your API? We'll say yes. I'm going to go ahead and it sees the relationships, again, because relational database, awesome stuff. I'll go ahead and say track these relationships, and with this step, I actually have a GraphQL and REST API ready to go. Like, that part I'm not getting paid for is doing REST APIs and creating CRUD APIs. I'm getting paid for building event-driven applications and products. If you're building products, the part of building an API that I just did here in 2 seconds is not the part you want to spend your time. You want to spend your time building out meaningful products that are going to deliver value to your customers. This is a difference between shipping a Corona tracker within 24 hours versus shipping one within 24 days. So this is a really powerful way to work when you automate the things that don't need to be done by hand. And I can verify for you that there's actually the GraphQL API here. We can see that it's fully functioning, things like customers, and then we can see the introspection working. Who here has not used GraphQL yet? A few brand new to GraphQL, cool. Definitely have a look at it. There's a lot of value there. If you want REST APIs, it's built in as well. But essentially, simple query language you're passing on to a server, and that server will break it down. In the case of Hasura here, let me go ahead and just paste in a query just so we can have a look at it. I'm going to grab this one here just to have a quick peek. If I analyze this, you'll see that what the engine is doing in this case is only queries can be explained. It is, all right, that's fine. Let me just give it a quick query. We'll say customers and first name, last name, make it easy. If I go ahead and analyze this, you'll see that what's happening is the engine here is making a SQL statement from this GraphQL query. So it makes a nice performant request underneath the hood. So have a look at GraphQL. It's a pretty cool platform, but again, REST is built in as well. So I have an API. Let's go ahead and actually use event-driven programming now. I have 2 handlers that I have written. Let me pull up my code editor here. And essentially what I have is just two handlers, 2 microservices that are living here. It's gone dark. There we go. Time to replace you. We have a /paid, and that's going to essentially just take in a endpoint where I'm doing anything handling the paid trigger. So as soon as my table in Postgres gets a paid trigger, I'm going to call this endpoint /paid. And anytime that paid trigger executes, it's updating a Boolean on my table for saying I've paid, and then it's going to go ahead and call my shipping endpoint /ship, and then this will update my table again afterwards when it's all done and say, yes, I've finished paying, I'm shipped off your product. Everybody tracking with that? I make an order, I hit pay, it sends it to the server writes back, says paid is good. When I get paid is good, it goes back, says ship the product. When shipping is done, it goes back and says, hey, shipping is good. Great. So here we have the system in place. To define events inside of Hasura, all I do is I come in here, and it looks like my event triggers definitions have disappeared on me, so let's see if I have to make these from scratch here. I do. That's fun. Make it even more alive. 10 minutes, we got this. So we're going to go ahead and create a new event trigger here, and I'm going to go ahead and call this my paid trigger. Actually, we'll make this be the paid trigger is good, and I'm going to go ahead and define the database that I want to track these on. We got into dark again. I'm not going to do anything secretive behind the scenes. Give it some tension. There we go. And then we're going to go ahead and say that we're going to be tracking on this public schema of Postgres. We're going to be looking for the payments table. I want to be notified when a payment comes in. I'm going to go ahead and say that we're going to turn on the console here. That just means that I can manually trigger this if I wanted to. But anytime that I have a new payment is when I want to go ahead and trigger off this behavior. And then I'm going to go ahead and paste in my handler here. I think I have in my history the URL that I used because it's Docker at the moment, so that's all fun. Save myself a lot of time if I had done this with, it's right here. There we go, look at that. /paid, even in my history. And then we're going to go ahead and just turn on cleanup. Actually, no, I'm not going to do that. That's an enterprise feature. We're going to stay away from there. That just auto cleans up my event table inside of Postgres. We're going to go ahead and say, OK, we've got the paid. We have the insert event, and actually, that's it. Create an event trigger, we're registering that inside of the engine, and so whenever I get a new insert on my paid table, this will go ahead and update. Good, that's the first event we need to handle. The second event we want to handle is the case of when I get the shipping, so I'm going to go ahead and call this one ship. Again, we're going to go ahead and define which database we're listening to. We're going to go ahead and put this on the orders table, and we're going to say anytime that I get an update specifically on the, we'll call it the shipped status or the paid status, we're going to go ahead and listen for just events on the paid column, and then with that paid column update, I'll go ahead and notify my handler that I have I'm ready to ship. And to do that, I'm going to go ahead and use the same API path. This one's just called ship. Let me fix what I just did there. There we go. Pay no attention to the messy icons on my desk. That's how you know I'm a real developer. OK, so we have the /ship. That should be good. And in this case, we're now having both of our events handled and registered. We should be good to go. And from there, what I'm going to do is go ahead and go to my data tab, or API tab. And I'm going to go ahead and kick off a flow here. To prove all of this, what I want to do is I'm going to use a subscription. So this is real-time data for GraphQL. This just allows me to have a WebSocket connection to be able to see all of my incoming orders. At the moment, I have no orders because I'm doing a filter on things that are shipped set to false. And so now if I come over to this little window here, what I can do is I can actually start to create a new order. So let's go ahead and grab that query. All right, insert orders 1, that's great. We'll go ahead and run this. What we should get is in a second, we should see that we've gotten real-time data on our subscription over there that we have an unshipped product. It's sitting there, order is ready, but I haven't paid, so, well, you know how it is. We're going to go ahead and grab the payment system now. And I'm going to look to see what my order ID was. It's order ID 5. So this is going to be what should kick off the whole flow now. I'm going to go and change my order ID to 5 here. I have the right amount of payment there for everything. Should be just fine. So as soon as I hit go on this, you'll be looking over here for the paid to switch to true first, followed by the shipped to be following shortly thereafter. So if everything works, we'll see. We're going to go ahead and give it a go. And we see that we get it paid and then automatically flips over. And so just setting up two small microservice handlers, I handled shipping, I handled paying, event-driven programming built into Postgres, and that's basically all there is to it. All of this here, last little piece to leave you with, is if we go into the settings tab here, I'm going to go ahead and go to the export metadata. And we're going to have just a quick peek at this. This is the definition of my entire server for how the GraphQL engine actually works. This guy's dying on me. It was a good one. There we go. This is the definition of the server. It's all open, it's all readable, it's all introspectable. Put it into code repository. Again, totally free. Like anybody who both experienced, you're probably thinking that's a lot easier than what I used to do. And if you're brand new, this kind of programming will revolutionize the way that you're able to work. You can build such incredible products if you start to embrace event-driven programming because it's scalable. It also allows you to reason about your architectures a lot better without making it overly complex with queue software you may not need. That's it. That's all I have. I'll be around. If you have any questions, find me. If you hated what I said, also find me, but that'll be fun. Motley Dev is where you'll find the resources, and thanks for listening.